In this video, we are going to talk about integration by using partial fractions. Before we solve the questions of integration involving the partial fractions, we will have to understand some rules of partial fractions. For example, let's say we have a fraction 3x plus 5 divided by x minus 2 into x plus 3. We can write this expression, this fraction, in a simplified form, and the rule for this is, let's look at this factor. It is 1 degree factor, means the power on x is 1, so it's a 1 degree factor. For every 1 degree factor you put an alphabet and 1 degree factor. Now x plus 3 is also a 1 degree factor, but it's different from x minus 2, so you put an alphabet divided by this 1 degree factor. A and B are unknowns, and later on we will find the values of A and B. But for now, just understand that if there is a 1 degree factor, for that in numerator we put an alphabet divided by that 1 degree factor. Let's say we have some numerator divided by x minus 2 whole square. Now look, in the denominator we have a 1 degree factor and on it the power is 2. So for 1 degree factor the rule is you put an alphabet and the 1 degree factor, but this time the power on 1 degree factor is 2, so new alphabet, but this time you raise the power to 2. Let's say you have now 3x plus 5 divided by a 1 degree factor and its power is cube. So the rule for 1 degree factor is an alphabet and the 1 degree factor. But now if there is a whole power on 1 degree factor, you put an alphabet in numerator and in denominator you raise the power of that 1 degree factor and keep on raising it till you reach the last power, and the last power here is 3. So x minus 3 cube. So this is the rule for simplifying given partial fractions. Let's look at another rule. Let's say you have x square minus 4. Now you can see that x square minus 4 is not a 1 degree factor, it's a 2 degree factor. There are different rules for 2 degree factor. First of all, you have to see that if it's a 2 degree factor, can this 2 degree factor be factorized? So to check that, what you do is you write x square minus 4 equal to 0. You find the values of x. So x values are plus minus 2. So yes, x square minus 4 could be factorized as x plus 2 into x minus 2. So from here you have x plus minus 2 equal to 0. So you have two factors, one is x plus 2 and another is x minus 2. So for a 2 degree factor, the first thing you will check that if it can be factorized, and we have seen that x square minus 4 can be factorized as x minus 2 into x plus 2. So now we have two 1 degree factors, two different 1 degree factors, and we know the rule for 1 degree factor, a over 1 degree factor which is x minus 2 plus b over another 1 degree factor which is x plus 2. Let's look at another rule. Let's say we have 3x plus 5 some numerator divided by x square minus 9 x minus 5. Now we know that x square minus 9 is a 2 degree factor, but we have to check that if this 2 degree factor can be factorized, and we can see that x square is equal to 9, which gives us x is equal to plus minus 3. So we have two factors, one is x minus 3, another is x plus 3. So we can write this fraction as 3x plus 5 by x square minus 9 can be written as x minus 3 into x plus 3 into x minus 5. Now in denominator we have three 1 degree factors. All three 1 degree factors are different. So the rule is a over 1 degree factor, b over 1 degree factor, c over 1 degree factor. So this is how we simplify a given fraction into sum of partial fractions. Let's look at another rule. This time we have 3x plus 5 divided by x square minus x minus 6. Again, this time in denominator we have a 2 degree factor. But whenever we have a 2 degree factor, we will have to check if we can factorize this. So x square minus x minus 6 could be written as x square minus 3x plus 2x minus 6. From the first two terms, x is common, x minus 3 plus 2 is common, x minus 3. So we know that x square minus x minus 6 could be factorized as x minus 3 into x plus 2. So every time you have a 2 degree term or 2 degree expression, you check that if this 2 degree expression can be written as the product of two 1 degree terms, and yes, it is so in this case. So we write x minus 3 x plus 2, and we know the rule for partial fractions now for 1 degree term, that is a over 1 degree factor plus b over 1 degree factor. Let's look at another rule. This time we have, let's say, 3x plus 5 over x square plus 4 into x minus 9. Now we know that x minus 9 is a 1 degree factor, so we know the rule is alphabet divided by x minus 9. But we'll have to check that if this 2 degree term or 2 degree expression can be factorized. To check that, we will put x square plus 4 equal to 0, x square is equal to minus 4, x is equal to plus minus square root minus 4. We know that inside the square root, negative number is not allowed. It becomes an imaginary number. So no, x square plus 4 cannot be factorized. So the rule for 2 degree expression that cannot be factorized is ax plus b divided by x square plus 4 plus an alphabet divided by x minus 9. Let's look at another rule. This time we have 3x plus 5 some numerator divided by x square plus 4 into x square plus 9. Now in denominator we have two different 2 degree expressions, 2 degree factors. As we have seen in the case of x square plus 4, which cannot be factorized, the same way x square plus 9 cannot be factorized. So two different 2 degree expressions, and the rule for 2 degree expression which cannot be factorized is ax plus b divided by x square plus 4 plus cx plus d divided by x square plus 9. Let's look at another rule, which is 3x plus 5 divided by x square plus 4 whole square. Now we know that x square plus 4, which is a 2 degree expression, and it cannot be factorized. So first we will put its rule, a 2 degree expression which cannot be factorized. The rule is ax plus b divided by x square plus 4. And now we will raise the power x square plus 4 whole square, because here the power was 2. And in numerator, since we have raised the power of a 2 degree expression which cannot be factorized, the rule is same, cx plus d. Just like in the third case, when you had x minus 3 to whole power 3, so when you raise the power in denominator of x minus 3 to square, in numerator you had still written an alphabet. Then in numerator you had written an alphabet. So if in this case you are raising the power of a 2 degree expression which cannot be factorized, so in numerator you will put cx plus d. Just like when you were raising the power of 1 degree expression, you had simply put one alphabet. Here the rule remains the same, cx plus d. Let's look at one more rule. Sum numerator x minus 2 whole square x square plus 7. This is a 1 degree expression, whole power is 2. It's a 2 degree expression which cannot be factorized. So we'll start writing the rule. A over x minus 2 plus b over x minus 2 whole square plus, for the 2 degree expression which cannot be factorized, cx plus d over x square plus 7. So we will follow all these rules to put the fraction in a simple form, in simple partial fractions form, and then we will integrate. But before we move on to the questions of integration, there are some basic formulas of integration. Let's have a look at that. Let's say you have to solve this integral 1 over x minus 4 dx. Now we know our basic formula, 1 over x dx is equal to ln x. To solve this integral 1 over x minus 4 with respect to x, we are doing it with substitution. We are supposing x minus 4 equal to a different variable. But before we suppose it equal to a different variable, we have to know that the derivative of this term x minus 4 is also written here. The derivative of x minus 4 is 1 because derivative of x is 1 minus derivative of 4, which is 0. So the derivative of x minus 4 is 1 and it is written here. Even if 1 wouldn't be here, we will just suppose that 1 is there. So x minus 4 derivative is there. We are supposing it equal to a different variable t. Differential, x differential is dx minus 4 differential is 0 because it's a constant. Differential of t is dt. So we have dx is equal to dt. We will plug it back in our integral. Dx is dt divided by x minus 4 is t. So it has become 1 over t dt, which we know that ln t by this formula on the right hand side. But t was not originally the part of our question, so it is ln x minus 4. Now please see this. What we have seen is 1 over x minus 4 integral is equal to ln x minus 4. So from now on, what you have to keep an eye on is that if there is something in denominator x minus 4 and its derivative is written in numerator, its derivative is 1, then we can simply write this integral as ln of denominator x minus 4, which was this answer. Let's have a look at this integral 1 over x minus 3 dx. Instead of solving this integral by substitution, I will make a quick check. That is, if there is something in denominator x minus 3 and its derivative is written in numerator, what is the derivative of x minus 3? It is 1. It is written in numerator. Then you can simply write the answer of this integral directly, that is ln of denominator, some constant. Let's say you have to solve this integral. So you can quickly check that if something is written in denominator x square plus 2x plus 1 and its derivative is in numerator, what is the derivative of x square plus 2x plus 1? It is 2x plus 2. It is written in numerator, so you can directly write the answer of this integral as ln x square plus 2x plus 1 plus some constant. Let's say you have to solve this integral x over x square plus 1 dx. Now let's check that if there is something in denominator, in this case it is x square plus 1 and its derivative is written in numerator. What is the derivative of x square plus 1? Its derivative is 2x. In numerator we have x but not 2x. So what you can do is you multiply it by 2 and you divide it by 2. It's a constant, it can be multiplied and divided. Now in denominator we have x square plus 1 and its derivative, which is 2x, is written in numerator. So I can write first of all 1 by 2, this 1 by 2 multiplied by ln the answer of this integral, which is ln x square plus 1. So the point is, if you have to multiply by a number and divide by a number, just so that you can have the derivative in numerator of something which is in denominator, so that you can put it in the form of ln of denominator, then you can do that. You can multiply and divide by a constant, but definitely you cannot multiply and divide by a variable. So let's have a look again. Let's say you have an integral x square plus 2x plus 1 is in denominator, and you have x plus 1 in numerator. So you have to solve this integral, but very quickly you can make a check, and that is, there is something in denominator. In this case it is x square plus 2x plus 1, and its derivative is 2x plus 2. It should be in numerator, but in numerator we have just x plus 1, but we need 2x plus 2. What we can do is, we can multiply and divide by 2. So it becomes 1 over 2 2x plus 2 divided by x square plus 2x plus 1 dx. Now we can see that in denominator we have x square plus 2x plus 1, and its derivative, which is 2x plus 2, it is in numerator. So now we can put it in the form of ln x, that is 1 over 2, this 1 over 2, and the answer of this integral, which is ln of denominator x square plus 2x plus 1 and some constant. Another simple example, if you have to find the integral of 97 over x minus 3 dx, then again take this constant out, 1 over x minus 3. The derivative of x minus 3 is 1, which is written in numerator. So we can put this in the form of ln, that is 97 into ln of x minus 3, which is the solution of this integral. So the answer of this integral would be, take 2 outside, 1 over x minus 4 dx. There is something in denominator which is x minus 4, and the derivative of x minus 4 is 1, which is in numerator. So we can simply write it as 2 ln of denominator, which is x minus 4 plus some constant. So we are going to use partial fraction rules and this integration concept when we are solving the integral questions by using partial fractions in the next video.